Good morning, good afternoon, good evening, wherever you are in the world. Thanks for coming to another Sawtooth webinar. We're excited to have you. Today we have Ben Cordiz. We're super grateful to have him today from KS&R, and he's going to speak on the state of synthetic data, governance, and the Echo Index. He also presented at our Sawtooth Research Conference in Berlin this year. So we thought we would invite him to present some of his learnings and insights to the webinar series. So excited to have him. Okay, a few details before we get started. We are here in Zoom, and we use the Q&A section to ask questions. Please don't use the chat. And we will have time at the end for a Q&A time, and Ben's happy to answer your questions there. So you can go ahead and ask them during the presentation, but there will be a good section at the end for Q&A. We do send out a recording of the webinar to everybody who signs up, and it's also posted on our website after the fact. Ben will be sharing his slides, but the way that you get them is by using the QR code in the presentation. So make sure to take a picture of that and to get the slides. Coming up next month, we will have another webinar on our series. September 17th, we'll hear from Chris Moore from Ipsos, who'll be presenting on synthetic data in practice, from boosting to digital twins. So you'll want to check out that webinar next month. Get that on your calendar. We always do Thursdays at 12 noon Eastern. In addition, November 3rd through 5th, we will have another MaxDiff certification virtual workshop. If you haven't seen these, they're new, but we've had a few. And if you take the workshop, you're able to potentially earn the certification for MaxDiff and post it on your LinkedIn. So a Sawtooth certification. I encourage you to check that out in November. And then next May 5th through 7th, 2027, we will be out in Washington, D.C. with another SRC, Sawtooth Research Conference. They are really great. If you haven't had a chance to go into one of those, please see if you can get it on your budget and get on your calendar for next year. And finally, if you're new to Sawtooth, we just highly encourage you to check us out. We're, of course, really well known for Conjoint and MaxDiff, but we're trying to get the message out there that you can do all your research with us. Really encourage you to check us out at discover.sawtooth.com. Okay, with that, I'm happy to introduce Ben Cortez. He's works at KS&R on AI strategy, development, and applications. He has over a decade of experience in advanced quantitative methodologies. He directs the data science team there using AI and predictive analytics across pricing, feature prioritization, and insights activation. He's very focused on rigorous research design, reproducible evaluation, and organizing AI so organizations can translate insights into measurable business outcomes. With that, Ben, hope I didn't butcher that too much. Let's turn on your camera and your audio, and we can see you and share your screen, and you can take it from here. And feel free to further introduce yourself.
All right. Thanks so much, Justin. I'm happy to be here and looking forward to sharing some of the extended work that we've been doing based off of the kickoff to our synthetic data evaluation back in May at the Sawtooth Research Conference. I'm Ben Cortez. I am the SVP over Decision Sciences and Innovation at KS&R, as Justin had mentioned. And I oversee the quantitative department, leading methods, AI strategy, tool development, innovation, and anything that really comes along with statistics, data science, or quantitative research. I'm really excited today to be sharing where we're headed with the webinar and what we've been learning about synthetic data in particular, and how we've been applying our own governance layer to this process. So we'll start with some definitions and alignment around what we mean by synthetic data. It's a broad category. Want to make sure that everybody is on the same page and has the same vocabulary, at least for today. Then we'll get into governance and the Echo Index. We'll talk a little bit about what it is, how it works, some of the details under the hood, and how we can evaluate synthetic data. And then we'll look into applying it to a handful of studies, what it teaches us, and ultimately some of the trends we're seeing with synthetic data and how to improve models or drive those discussions with your clients. And last, I'll share a bit about our own expertise and practical guidance we've learned from doing a handful of these synthetic studies, both internally as well as with some of our clients. Um, First, I want to make sure we're on the same page with what we mean by synthetic data and those definitions. And one other admin thing as a call out that can scan the QR code in the bottom of these divider slides. It'll bring you to a landing page that has the slides from today, as well as some other information about the Echo Index and what we're doing. So synthetic data is broad, and there are a bunch of definitions and buzzwords floating around. So I want to level set everybody on what we mean by synthetic data. First things first, synthetic data does not necessarily mean Gen AI, LLMs, etc. There are a handful of these types of techniques that do require that technology, but some do not. So if we think about those that don't, one of the earlier statistical techniques, extrapolation, something where we are generating insights that go beyond what we actually saw in the data using predictive models. That is considered synthetic data. Typically used in pricing research, something that I do quite a bit of, going beyond the bounds of price ranges that we might have tested to get an understanding of willingness to pay for certain products or services, etc. As I mentioned, this doesn't have anything to do with the data that we originally saw, or I guess there's no way to validate it with data that we originally saw. So the confidence in these types of techniques is low. And we'll see that across the board with a lot of these synthetic data challenges. It's difficult to understand when we have high confidence versus when we don't. So another long-standing technique, imputation. Ultimately, this is filling in the missing pieces in a data set. Does not require Gen AI at all. And there's actually a great paper by NIQ comparing some of the LLM approaches to standard stats approaches for imputation that was presented at the Sawtooth conference back in May as well, that showcases why LLMs might not be the best use case for this. We use this from time to time, typically when we want to run regression analysis or other KDA style techniques when we have incomplete data. So don't know or NA responses or other reasons why respondents might not have answered a full grid. We know that this is a really trusted and reasonably accurate solution. It's been in place for a long time. And this technology was actually then used to create the first set of sample boosting, which also does not require LLMs. And when I say sample boosting, here I'm talking about generating respondents that didn't exist. So your data set, you want more responses. Ultimately, we use sample boosting to generate new rows to our data set to be able to boost niche subsegments that are hard to reach or reduce the overall sample size for a particular study. Because this is grounded in existing trusted technology, we have some confidence in this particular tech, and we can evaluate it. And that's really where we're going to focus a lot today, is on evaluating sample boosting and understanding when this type of technique works and where it falls short. Then we move to really new cutting edge tech with digital twins and synthetic personas. Both of these do require Gen AI, meaning you need an LLM in the back end to produce this type of output. When we think of digital twins, these are one-to-one copies or mappings or projections of something, whether it be a human, a process, a system. Ultimately, these models are designed to represent the behaviors and attitudes and actions of those systems that they're trained on without actually having to go and talk to the original. These generate net new insights that never existed. These are very, very challenging to validate unless you're in a controlled statistical experimental design environment where you have holdouts that are intentional for the research. So in production and in practice, it's nearly impossible to validate these from a fidelity and accuracy standpoint. Ultimately, you make the decision you're going to make based on the data, and that's the validation. Synthetic personas are kind of more qualitative than everything else we mentioned. The other four categories here have been purely quantitative, but those are really aggregate generators. Think about having a at-risk customer group. For a digital twin, you may create 100 at-risk customers and use that to get your answers. A synthetic persona, we would create one model that's an aggregate representation of that audience and be able to interrogate and interview that audience qualitatively through, typical chat interfaces or other mechanisms to get that data. Similar to digital twins, the confidence in these outputs is pretty low. However, the use cases for synthetic personas tend to be lower risk. So there's actually quite a bit of promise with these methods, given you can do more directional early stage testing and do things pretty quickly. But we're not going to focus on the qualitative side of things. Really going to stay within the quantitative elements today. And for those visual learners, this is a great representation of where we're going to stay. So if you think about your existing data set that you work with every day, you're in the upper left-hand quadrant here, that number one, your real world data. This is how we have historically done research prior to the onset of synthetic data. And then we move into sample boosting or adding new rows, which are those green rows below our existing data. So it takes in source data and produces new data in the same structure and format, and hopefully, if it's done well, mimics the behaviors of the original seed data. Doesn't require LLMs. We have reasonable confidence in this tech, and we can evaluate it. Then we move to digital twins, and that's on the upper right-hand side. Those are new columns. So now we're creating answers to questions that were never actually asked of the real audience. And so here, validation becomes really challenging unless we've designed a mechanism within our study to measure how accurate those synthetic responses from those digital twins are based on real data. And there's no guarantee that if these responses worked on something you tested, that they'll work on something you didn't test. So there's inherent risk in terms of digital twins and the way that they're applied. Something to keep in mind if you're looking to explore with digital twins, that you should be really considering how sensitive or critical that decision is, or how far along you are in the product development process, for example. Early stage testing and low risk decisions are the best place to play for digital twins. Then we get down into the lower right, which are synthetic audiences. And these are ultimately off the shelf, no real training data used to supply to these models, and using them to conduct net new research. I consider this the Wild West. There are plenty of providers out there that offer this type of service. There's no real way to validate this type of activity aside from, again, digital twin validation, but even a structured style of evaluation doesn't really exist because there's no training data to then produce holdout tasks for this type of audience. So you can see the spectrum and scale of where synthetic data goes from a quant perspective. And we are going to focus on two, which is sample boosting today. So we've developed the Echo Index, which was created to focus on the fidelity of sample boosting. And we started with sample boosting for a couple reasons. So first and foremost, sample boosting is the closest to traditional techniques that are proven to be accurate, like imputation, as I had mentioned before. We also have robust and well adopted and accepted tools to evaluate sample boosting that don't exist for some of those other techniques. And so we can fold in a portfolio of metrics that help us have an understanding of how well the synthetic data is aligning to the real world data, something that doesn't exist for these other synthetic approaches. Digital twins are exciting though. So we're not going to completely ignore them, and we're going to ignore them today. But going into the future, we are building an extension to our Echo Index evaluation to be able to accommodate structured evaluation of digital twins through holdout tasks and other intentional survey design mechanisms. However, today, the evaluation doesn't exist off the shelf unless you've done that careful planning. So stay tuned for the future as we continue to work on our comprehensive governance framework for synthetic data. So you may be wondering, how does the Echo Index work? So ultimately, it is a novel approach to looking at measuring the fidelity of synthetic data by not creating holdout tasks and comparing the performance that way, but ultimately building a baseline distribution that we can compare the synthetic data performance to that's generated for any standalone study. And so I'll walk through the details and how it works over the next series of slides. But that's the core takeaway is that any study you have where you have already done synthetic or are looking to do synthetic, we don't need to change it. We can take that off the shelf data, evaluate it, score it against the synthetic, and see how it performs. We take two approaches to this. We have a statistical side and a machine learning side. The stats side ultimately measures the shape, the spread, the relationships of the synthetic compared to the real world data to make sure that they are similar. We don't want the synthetic data to be introducing, a skewed distribution with our top two box scores and influencing that in a way that wasn't present with the existing training data that we had used for our human sample. That's not enough though. We also need a machine learning side because these models can leave behind artifacts that are not detectable from the statistical evaluation, where ultimately we look at a classifier and we want to understand, can we tell the difference between a real data point and a synthetic data point? If we can, that means there's a problem with our synthetic model that is leaving something, some breadcrumbs behind that we can't see with the statistical evaluation. And so pairing these two components together gives us more of a holistic understanding of the synthetic data performance and helps us have more confidence in anything we're going to do downstream with reporting. It starts by first looking at that real world data only, and we build a baseline distribution off of that, which I'll get to in a little while. Then we score the synthetic data, and we see how close that score was to our baseline distribution. So what is actually scored? How does this work? Well, the statistical scoring uses three key question types and those that are close to these, which cover a majority of questions that we include in a typical market research survey. So the first are numeric or Likert scale style questions. So scale of 1 to 5, on a scale of 1 to 10, how willing are you to recommend a specific brand? Or, how willing are you to switch from a current provider? Those we can treat as numeric and use all the traditional numeric scoring and evaluation techniques. Then we have single choice questions. So looking at a specific set of brands, which one do you purchase from the most frequently, or which one is your favorite? And then expanding to multi-selects, ultimately understanding being able to select multiple brands, multiple favorites. And the nuance between those is subtle, but ultimately we know that synthetic models have a challenging time clicking the same number of boxes in a multi-select as a human. And so we treat multi and single selects differently for that. So we ultimately have a secondary test that helps us evaluate those multi-selects. Other less common and unstructured questions are omitted for now because this still gives us a pretty good coverage of the general surveys that we would run. Also, it's important to note we are not including advanced analytics. So conjoint, max diff, etc., are not included in the current evaluation. In terms of evaluating, we look at two things. We look at the distribution. So is the shape and the spread from the real data similar to that of synthetic using three different divergence and distance metrics? And so we have an ensemble approach that rolls those scores up into a single distribution score. We also look at the relationships and dependency. So I had mentioned KDA earlier. If you want to run a driver analysis, it's really important that your synthetic data has the same relationships, not just the same shape as the real data. Otherwise, you will get a different rank order and different magnitudes of importance for those variables when you run your analysis. It's also important if you're looking at segmentation or other downstream analytics that rely on those interrelationships between variables. And so we've split those based on which question type we're looking at to be able to measure the similarities or differences in those relationships. So all of this gets rolled up into a single statistic score that helps us understand how well the data looks compared to the real C data. On the machine learning side, we take a similar ensemble-based approach where we look at three different classification methods, logistic regression being old but useful and fast, all the way up to XGBoost, random forest in there as well, using some more modern techniques. Chose these because there's a blend of what these are looking for, how they classify things, as well as the fact that they're scalable. So there's a minimal need for hyperparameter tuning with these models, which means we can pretty easily apply them to just about any data set. On top of the three different classification methods, we add in three different success metrics. So we have 9 total machine learning scores that are coming out of each one of these evaluations. And we use these as a measurement of how good that classifier is. So in this case, if your classifier is good, meaning you have high success metrics, that means that your synthetic data looks different than your real data. That's bad. So we actually want our classifiers to fail here, which is different from a typical data science problem where you want those classifiers to perform well. In order to pull this all together, we use tenfold cross-validation. We actually don't have a holdout set for this because we are just looking at understanding how well these perform across those folds, as well as ensuring we have enough data when we look at small segments for small sample boosting, because that's one of the critical use cases of sample boosting. And including a holdout can really lead to deterioration of some of the success metrics, especially F1, if we have small data. So pulling this all together, I want to go through the full pipeline, how this works so that everyone can understand what we're using to measure synthetic data before we get into what's happening, because it's really important that we drive transparency in evaluation and what's going on under the hood so that everyone can be aware of the way these models are being graded and tested. So first, we start again with just the real data set. Synthetic doesn't matter at this point. We're going to take and we're going to generate 2 partitions via bootstrap subsampling, and we're going to call one of them real and one of them synthetic. These are going to be the same size as the original data set, so we are looking at the same comparisons we'll have when we look at the real and synthetic comparisons. We repeat this a bunch of times, creating a bunch of these matched pairs of bootstrap partitions. Then we score them. So we wind up with 100 or so scores of the echo index, as well as everything else that we had under the hood with the statistics and machine learning scores. And that's our baseline. So we have a smattering of what that distribution is going to look like. Now we can score our synthetic because we have a baseline to compare it to. No holdouts, just using the real data. We run the echo index on the synthetic compared to the real now. So now we really do have a real and we really do have a synthetic data set. And then we measure how close is the synthetic data to the baseline. And by close, we mean an effect size of plus or minus 3.5 or less. And we use that because it gives us a pretty good gauge of how close the synthetic is to the real without being too strict. You can use whatever threshold that you like, but ultimately we found 3.5 to be pretty effective in terms of measuring fidelity. So when we pull this all together, you see the chart on the lower left. This is what we would expect our output to look like when we score a synthetic model. So you have a bunch of your jitter data points for your baseline distribution on the left. We have our synthetic model single score on the right. And does that synthetic model fall within plus or minus 3.5 of 3.5 standard deviations of the mean of that baseline distribution? It's important to note here that the scale on the left-hand side doesn't really matter. It could be 0.01, 0.02, it could be 0.07, 0.08. Ultimately, what does matter is the relativity of the synthetic model scoring to the baseline distribution. And again, that's what makes this flexible and adaptable to any data set, is that the scale doesn't really matter. It's how well does it compare to that distribution overall. So before we get into applying this to actual data sets and seeing what the performance truly looks like, we have the difference that's critical in understanding of fidelity versus utility. And this is something I'm sure some of you have heard of. Does fidelity matter if utility is solid? Well, ultimately, when we talk about statistical fidelity, we think about how well does the synthetic data preserve the properties of the real data. Is it changing the spread, the shape? Is it introducing artifacts that are going to skew any downstream analytics? And then ultimately using all of our evaluation that exists for fidelity testing to feed into a roadmap for enhancement, improvement, adjustments, etc. We almost never see one-shotting a synthetic model as being successful. So in order to make sure we have a roadmap, we need these fidelity evaluations and comparisons. If we just jump straight to utility, which utility is the decisions that would be made from that data, was it useful? Did it actually get us to a point where we made a good decision? If we just jump straight to utility and we're wrong, we have no diagnostics about how, why, where. Fidelity gives us a roadmap and gives us the absolute best opportunity for utility downstream and allows us to iterate and explain and defend, should we get to that point, where we need to address anything that happened with the synthetic data itself. So when we get into actually applying the echo index, we'll start to see how some of this comes together with the baseline distribution, scoring, and building out that roadmap for enhancement. So our exercise that we'll discuss today is an extension of what we were working on back in May and includes 5 synthetic providers, 3 of which use traditional methods, so statistical, ML, deep learning. 2 of them use LLM-based synthetic data. We looked at 2 different data sets. We had Paxton and Yang, which was presented at QuantUXCon back in 2024. Conference is upcoming again this fall. If you're interested, it's a great one. Strongly encourage you to join. Where there were 11 questions with this data set, 2 of them demographic and 9 of them attitude and behavioral. GenPop consumer 518 human responses, ultimately based on focus and trust in tech. So something that should be pretty easy for any of these synthetic providers to solve. Then we wanted to make sure we were testing something that was really hard. So we looked at the Twin 2K500 dataset, which was developed by researchers at Columbia, ultimately intended to use as training data for digital twins. And so the questions in here are really complex. They are kind of strange, non-standard market research style questions covering a broad range of topics. And so our hypothesis was that if any models were going to pass our echo index evaluation and scoring, they would pass on Paxton and Yang. And that was the intent, was to showcase, hey, there's something we can do with synthetic data. But can we really synthesize an entire nasty, ugly, big market research study? We didn't think so. And that's why we put in Twin 2K to have those bookends of super complicated and super easy. And so let's go ahead and see ultimately what the results were. So with Paxton and Yang, we actually saw success, just like we thought. And so this is excellent. This is a proof point that showcases across the 5 providers tested, we're looking at the left-hand side, each one of their effect sizes from the echo index falls within the bounds of that 3.5 effect size. And so the other really interesting piece here that may surprise some of you is that the LLM providers have no real distinguishable effect sizes that are different from the stats ML deep learning providers. The original hypothesis was that LLMs were bad at this. Well, this chart surprised me as well and showcases that the LLMs really aren't any better or any worse than traditional models for generating synthetic data for sample boosting. So good news. There's some hope for synthetic data after all. But before we say rubber stamp, yes, this is good, let's move forward, let's look at the actual question performance. Is there something hiding beneath these good scores that might be cause for concern? So here we see all 9 non-demographic questions on the right-hand side. And this is based off of the echo index statistical component score. So remember, there's the stats component, there's the machine learning component. This is just the stats piece. It gets a little bit busy and ugly if you have both the stats and the ML at the same time. So for the purposes of this evaluation, you can see, at least from a statistical perspective, all of the points look like, a scattershot. There's no real clear story that says LMs are better here, stats, deep learning is better here, this provider is better than that provider. It doesn't really exist. And this was really surprising, again, because there were some of those preconceived notions that I had, and I'm sure many of you on this webinar had as well, that said, LLMs can't do this. Well, this opens up the possibility for sample boosting across providers and models, given what we're seeing for this simple study. The one call out here that's really critical, and I want you to keep with you through the next set of slides, there were only quasi-numeric questions in this. Only agreement scales. Nothing fancy, nothing complex, no skip patterns, none of that. So ultimately this says we can solve the easy problem, or at least we should expect to solve the easy problem because we did it once. And this is one shot. I didn't do any manipulation, any editing to the data files themselves. Simply received it, scored it, and this is what was produced. So good news. Now let's look at the hard one. Let's see if we were right. Same chart on the left as we saw before. Now the effect size bands look really small. Again, the scale doesn't really matter. I think the key here is that no single provider came anywhere close to solving this problem. And this was, again, our hypothesis was that if we had a big, ugly, nasty study, it wasn't something that we could just synthesize. And this is one shot again, did it the first time, no iterations, no adjustments. The other interesting piece, though, is we see a similar story. Aside from provider C, we see LLMs and the stats ML deep learning similar. There's no real differentiation between the performance of these. So the preconceived notion that LLMs perform differently than this, at least right now, seems to be false, which is really surprising. But what is it that's driving such poor performance? Is it everything? Is it a handful of questions? Well, let's take a look and see. So I have a similar chart on the right-hand side. I tried to fit all 500 questions on here. Didn't work. So I decided instead we'd filter on the top 30 worst performers. So these are the 30 poorest performing questions from an individual question level from our Echo Index scoring. Again, a great way to showcase how the models are working, where they're performing well, and where they're coming up short at a question level. This is still just the stats component. I'm sure the story would be different if we showed the machine learning components, but that's not included today. Other thing to note is that now we have three categories, right? This study had all the different question types, and then some we had to exclude because they didn't meet our numeric single select or multi-select criteria. So at the top, we see this cog card exercise 2. Everybody was fooled. This didn't work at all for any of the models, really far away from our baseline. Then we have some financial literacy questions and some other bias questions where we see an interesting cluster, right? All of those providers and models that failed together. There's no real differentiation between the LLMs and non-LLMs about why or how they failed. But something's different about these providers. And why did provider A succeed here? And why did provider A and B succeed here? Things we'll get into at another time when we have more time to dive into the providers themselves. Then we see similarity again, ignore provider C. There's adding some noise here. But we can see these two OE questions down here. The LLM, both times, did a great job. The stats ML deep learning did not. And I know that looks small, but that's a very, very detectable problem from our classifiers that will immediately spit out what's real and what's synthetic. So we see nuance despite kind of equivalent scoring overall from those effect sizes. We do see some nuance in terms of who's doing this well and who has room for improvement. And also a roadmap for either adjusting the models or removing some of these questions if they're not very important. But I bet you're all wondering, what are these questions? Because these semantic names are nonsense and not helpful. So let's get into that next. So we want to look at what are those questions and some hypotheses about why they broke the models. So the one question that fooled everyone was this cognitive card exercise, likely due to erratic training data or perhaps some other coding issues under the hood. But ultimately, this question was an interesting logic puzzle. So you have 4 cards in front of you. Each card has a front and a back, and on one side is a letter, on the other side is a number. The cards that you see in front of you are A, F, 3, and 7. If you were told that there's a rule that says every card that has an A on one side also has a 3 on the other side, what cards exactly would you have to turn over to prove or disprove that rule? Well, if you look at what we see on these responses, put in the chat what you think the answer is, and I'll reveal it at the end. Key here, though, is none of these models were able to replicate human behavior. It's not if these models were right or wrong, it's that they weren't able to replicate the training data that we provided to these models. That's going to be even more important here. So those that fooled the LLM, but at least one traditional style model was able to succeed. were on these financial literacy and bias or these valuation of mortality questions. So the financial literacy questions were just basic true or false questions. So, how does a 15-year mortgage work versus a 30-year mortgage? Can you lose money in the stock market? How do IRAs and retirement plans work? So these questions here, the LLM, my assumption, is the LLM knows the answer. So it got them right. People probably don't know the answer to all of these. And that's where some of this came in terms of the discrepancy between human knowledge and our perceived synthetic data. This is a huge problem because if I am a financial advisor or I am trying to educate my clients on the behavior of personal finance, I need to know what humans think and what humans know about this, not what LLMs know. And so if I can't correctly predict with synthetic data this type of performance, I can't use it because it's not going to help me make a good business decision about how I can better inform my clients. The valuation of mortality, this one's a little bit weird, but ultimately there was a series of these questions that are very long, so I only included one. This one was you have gone out to the movies and you were exposed to a rare and fatal virus. The odds of contracting the virus are really small, 4 in 1,000. But you can get an injection that's really hard to come by that will reduce your odds of contracting the virus to 3 in 1,000. There's very limited supply of this injection, and they're only going to make it available to the highest bidder. What's the highest price you would pay to be eligible for the injection? I'm assuming here in this case, that data is very noisy and very personal. And when it comes to some of these statistical models, they were able to replicate that human pattern, whereas the LLM was not. So more differences, more dependence on model and provider, but questions, at least from the financial literacy standpoint, that are really impactful for research in terms of the decisions we may make downstream if we're using synthetic data. The last pieces where the LLM did fantastic and the other traditional models did not. We had two questions there. The first was a very easy percentage question. The chance of getting a disease is 20 out of 100. This is the same as having a what percent of getting a disease? Obviously, it's 20%. LLMs would know that. My assumption here is that the humans all knew that as well. Yet the stats and ML models are trying to blow up the variance because there's a little bit of nuance and they don't just want to pick 20 every time. Didn't confirm this, but that's my hypothesis. Same thing goes for the lily pad question, where you have a patch of lily pads that doubles in size each day. And after 48 days, it covers an entire lake. So how long, in terms of number of days, does it take to cover half the lake? It's 47 days, assuming most of the humans got that right. There was one traditional model that was able to solve this successfully, and the LLM did as well. So there's still no real rhyme or reason to what's happening with these LLMs or non-LLMs or providers. This is why governance is so important. So you can drill down, see where the differences are, understand model behavior, and make adjustments and know where the highest risk is with low fidelity when you're using synthetic data. So I want to provide some practical guidance and just pause here for a minute for anyone who's interested in getting the deck or other information. Go ahead and scan that QR code in the bottom, and you can go ahead and grab it from there. So moving on. This exercise demonstrated there is some potential, some real potential for synthetic data, which is great. Not what we expected, but certainly something that was interesting beyond what we thought we would find. So simple, straightforward data seems to be a really strong starting point, especially if you're just looking at agreement scales or numerics, but not open numerics based on what we saw before, depending on the question type. So be careful about what we mean by simple and straightforward data. Comprehensive, complex data, we know we're going to have to make concessions. So if we were using the Twin 2 case study as a client deliverable, there would be iteration, adjustment, pruning some of those questions that aren't working, or having those trade-off discussions with the client about, do we really need these? Are we willing to make that or take that risk of low fidelity synthetic because we need those questions included? And the key here is the only way to know this goes back to fidelity measurement and governance. Utility isn't going to tell you what was wrong. You're just going to make a wrong decision. So how does this work in a day-to-day project? First we get the request to use synthetic. Maybe it came from leadership, maybe it came from a client, but ultimately, or maybe you're curious. But ultimately, we need to understand why. What are the hypotheses? Are we using synthetic just to use AI? If so, probably not the best use. We need to make sure the hypotheses are specific so we can address them with synthetic data. There's definitely some planning and refinement and negotiation about what those hypotheses are, what synthetic can actually address. And if you're thinking about using it, it's critical to do some soul searching and understanding about why. Because if you can't answer the question why you're using synthetic, that's the starting point. So you've got to get over that. Then we can generate some synthetic data and score it. The Echo Index then provides that roadmap that we saw, where we get individual level question performance as well as overall fidelity. And from there, it becomes a trade-off collaborative discussion. Are there key questions like NPS or willingness to pay or brand trust that we need to have in there because those are KPIs that we want to report on? If they're low fidelity, what do we do? How does that impact the viability of sample boosting? Maybe we need to throw it out and go to a different provider. Maybe we need to rethink synthetic holistically overall. If we're good there, then are there ancillary questions that don't really impact reporting that have low fidelity and are causing those models to blow up? At that point, we can have that discussion, prune the data set, look at those models, et cetera, and make those adjustments. But it's key at the very end of this step that we're not losing the core objectives of the study, because if we are, why did we do this in the first place? Right? We want to make sure we are still using synthetic as a tool, not that silver bullet. This iterative process includes quite a bit of rescoring, going back and forth, updating, iterating, etc. And then finally, once fidelity is achieved, meaning we have solid Echo Index scoring, we can look into utility, which means reporting, giving recommendations, and continuing down the line. At the end of the day, the end goal of all of this is to enable trustworthy use of synthetic data. So, our contribution to the industry is the Echo Index. Is this enough to get us where we want to go when it comes to measuring and trusting synthetic? Is there more to be done? I welcome that conversation because I think a lot of us are in that same place of trying to understand what's going to work, how do we evaluate it, and how do we make sure that we are buying or being sold something that's actually viable that can help us make better decisions. So a handful of best practices have come out of our experiments with the Echo Index as well as the studies we've been working on. Many of these we've already stated, but I'll bring them up again just to close the loop with everyone. The model and provider matters, but it's not clear why. So there's no clear criteria that separates LLMs and deep learning or ML approaches, which really surprised me. And I think it's great. It means there's a much bigger pool of potential models out there that we can use to solve these problems. But you have to measure and understand what's working and what's not. Beyond that, question type does matter. So likelihood agreement scales seem to work fine. We saw even with Twin2K, the only numeric style questions that were cause for concern were those that were those open ends. So an open question about an open numeric versus more of a 7 or 10 point scale. We haven't seen a clear base size rule. I know some of those have been published elsewhere, but ultimately you would expect that if you have more data, it would help with better sample boosting. We don't see that. We've actually seen that big data sets in the middle of a study right now that has data sets with 4,500 completes. And we're seeing the same challenges. So big data doesn't necessarily imply quality synthetic. So my recommendation is run it, evaluate it, see how it works. If it comes out clean, great. If it doesn't, make the concessions, go through the roadmap. And expect iteration. Compare this to segmentation a lot, where when you run a segmentation, you have collaborative discussions, you have trade-offs, and then you land in a place where everyone is at least somewhat satisfied with the end result. The same as with synthetic, is you're generally not going to be able to one-shot that data set and have a successful result. Some things to avoid when you're looking at using synthetic, a broad scope. Talked about this in the last slide. If you don't know why you're using synthetic, don't use it. There needs to be a real reason, and it needs to be a tool that's used along the way to solve a specific problem, not a one size fits all silver bullet to solve your research challenges. Um, if you don't have any training data, you're actually not in this sample boosting we've been talking about. You're in that lower right-hand quadrant of synthetic audiences that we talked about that is very much the Wild West. So certainly not something we recommend. Really complex studies aren't necessarily pitfalls, but it means you are very likely to have concessions in terms of the questions you can include, the types of models that will actually work to produce viable synthetic data, et cetera. So be very cautious with the conversations you're having with your stakeholders or clients upfront if the survey is very complex, because the chances are you're going to have to drop some things along the way to reach that high fidelity synthetic data. And the last piece is any synthetic provider self-assessment. Those are great. We expect and we should be asking for anytime we're going into business with a synthetic provider to produce documentation, evaluation, validation. However, that's not enough. There needs to be an independent governance framework that's applied to that data, something like the Echo Index, that helps you understand from a third-party perspective, am I actually getting what was promised? So the bottom line is, like anything that's new and interesting, start small. Work with something where it's low risk, you have a bit of time to navigate if you're learning about how to use synthetic and apply this process, or if it's already in production, think through how you may want to adjust your workflow to add in some governance layer. So today we focus on sample boosting, but there's a bit more in the pipeline. So we are going to be pulling together a comprehensive state of synthetic report that will include much of what we discussed today, but goes into more detail simply because we don't have time constraints. And we'll also be releasing the names of those providers that were included in this study. That's going to drop sometime in September. Go ahead and connect with me if you're interested in receiving or learning more about that report. We're also building a study that balances Paxton and Yang and Twin 2K that will help us find, hopefully, the middle ground of where we can expect synthetic data to be successful, hopefully with a one-shot exercise, if not with minor iterations, to get to a place where we have trust in high-fidelity synthetic data so that we all have a better recommendation about where we can use this technology in our workflows. As I mentioned earlier, we are extending the Echo Index to a digital twin framework. Stay tuned for that. And the full methods and early findings that we presented back in May will be released in the SRC conference proceedings coming up this fall. And the evaluation is open. We'd love to include more folks in this exercise to provide a more holistic benchmark of where synthetic data, particularly sample boosting for now, is with our industry as a whole. So if you are building or using synthetic data, feel free to reach out. We'd love to start that conversation. And if you're interested in more, scan the QR code, send me an email, connect with me on LinkedIn, grab the slides. You can also get the technical white paper that outlines much of the details and some beyond what we included in the presentation today about how the Echo Index works and ultimately what we've seen in terms of applications in using it in synthetic research. So with that, Justin, I'll turn it back over to you.
Yeah, thanks. Good job, Ben. Very interesting. Yeah, make sure you get your, maybe I'll share my screen real quick, but maybe we'll have to come back to yours for that QR code. Make sure everybody has that.
You want me to put it back up?
Just give me 1 second here, just for some last announcements here. So just a reminder, next month we have synthetic data, more on synthetic data from Chris Moore. Very smart individual, and I encourage you to check that out in September. We have our MaxIF certification workshop coming up in November. Make sure to check that out. Opportunity to win or to earn a certification. And then the SRC next May in Washington, D.C. Really encourage you to get that on your budget, put that on your calendar. Talented folks like Ben will be presenting there next year, and just a great event. And yeah, check us out. Sawtooth is easier to use than you think. Um, and we encourage you to check us out if you don't know much about us. Ben, why don't you go back and share your slide instead of my final one because you have that QR code,
Sure.
and we'll get to the Q&A. I have a simple question for you. Um, what's the main motivation that people have for using synthetic data? And I'm guessing it's cost.
So, I mean, that's a really tricky question to answer because it tends to be organizational dependent, depend on individuals, and generally based on what leadership is pushing. So the shortest answer I can give is it depends. But often we'll see there's a push from leadership that has been sold some sort of synthetic data, something, and think that it's going to solve all of their panel problems or data collection problems. And those problems tend to be speed, cost, accuracy. And so when it comes to speed, synthetic can certainly be faster than traditional research. However, it takes time to build the infrastructure in the model. So we've seen the most efficiency come from tracking studies where they are repeatable. Ad hoc studies, you tend to put in all this effort, and while we were trying to save time, but we just spent a week iterating on the synthetic data and the model to get it to a place where it works. So
Yeah.
speed, sometimes, depending on how much infrastructure you have in place. Cost, certainly, but at what cost, right? You're trading off accuracy for cost. So it really depends on what the audience is, what you're actually trying to accomplish, and the rationale behind synthetic itself. And then accuracy, I stand firmly behind this as a data scientist that your model, what you're building synthetic data off of, is a model. It's a prediction. It's never going to be better than the real data itself. So anyone who believes that synthetic data is more accurate than human data, it's just not possible from my perspective. Hopefully that helps answer some of your question, Justin.
Yeah, and this is also just a follow-up that's probably going to be impossible for you to answer, but how much of a cost savings is it? Is it like half as much? Is it a little bit cheaper? What kind of cost
Audience
savings do
dependent.
folks?
So
Yeah,
if you're doing B2C, human samples relatively affordable, at least in the US, if you're doing Gen Pop. If you're doing niche B2B, and I see some of that stuff is here in the Q&A about like healthcare and those really hard to find C-suite folks, you're paying, 80, $100 for a complete, then synthetic can be much, much, much more cost savings. But typically, if you're doing research with those audiences, there's a lot lower margin for error in terms of the decision that you're going to make based off of the research. So it's all a trade-off.
yeah. Sorry, I failed to mention we have Aaron Hill from Sawtooth with us as well. Aaron, feel free to jump in with any questions you might have. So, Ben, if you want to bring up the Q&A dialogue there, and you can go ahead and read the question and answer it, that'd be great. And I'll manage kind of cleaning them up as you go.
Sounds good. So we've got a question here that says, how would the assessment change if we are looking at creating new variables that are strictly a function of existing variables in the training set? So calculated fields, really good question, because oftentimes we want to have a composite index or some other metric in our survey that is sourced from a handful of questions folks would have already answered. Um, Anything that is a linear combination of known data should be omitted from scoring. We know the answer. So ultimately, we should remove that from scoring and then bake those calculations into the synthetic data as well. Otherwise, we're going to be cheating the system in one way or another. We're either going to be giving the synthetic data a better score than it deserves because the algorithms have figured out that function, or we're going to be hurting scoring because the algorithms haven't figured out. So if it's not net new information, leave it out. When it comes to the next question, definition of the echo index. So really good call out there that ultimately the echo index is the combination of that machine learning score and the statistics score. And so if you're looking for the details of how it's created, the formulas, go ahead and grab the white paper off the website. It's all there. Or that'll all be published in the conference proceedings as well. But we didn't want to go into that level of technical detail for this particular conversation, just to make sure we kept it high enough level for everyone to follow along. But it's all out there. Go ahead and grab it. And if you have any questions, reach out directly to me. Is there a limit to how much you can boost a small sample? So it depends on who you talk to. A lot of the providers that we worked with when we were doing this evaluation ultimately provided us with several series of sample boosted files. So it was anywhere from doubling the sample size to 1x all the way up to 10, 12, 15x. There are providers out there that are firm that say you must triple the size, and that's the optimal. I have absolutely no opinion on what that threshold is. I haven't done the research. But in terms of sample boosting, it is very common to go well beyond doubling the sample size, at least from the providers that we've talked to. The Echo Index is flexible enough to measure various types of boosts beyond just the doubling, but it's not something that we've explored in any level of detail to date. But a good suggestion for where we could go in the future. Um, have we tested this with healthcare? So the key to the Echo Index is that it doesn't care. It doesn't care the audience. It just looks at the data. So the model cares the audience. So the question here becomes, since we tested two Gen Pop studies, we saw no real material difference between stats, ML, deep learning, and LLMs. If we did it on a niche audience, would it be different? I bet it would be. I mean, we already saw in Twin 2K there were nuances and differences among the types of questions that the LLM was able to answer successfully. Mind you, it was one LLM provider in that study, so it's not a comprehensive evaluation. But I would believe that with a healthcare or a fintech or a executive type audience, we would see differences in the model itself from an LLM versus non-LLM perspective. So, I've got a question about what value do we see in using sample boosting for small subgroups in market research? So, the value here is being able to report on the unreportable. So, let's say you have a niche competitor audience where you can only get 35 or 40 completes out of your 10,000 complete brand tracker, but you know that they are a growing competitor and you are really monitoring them. You could report out on those 35 completes, to your executives, but it's probably going to feel a lot better if you double, triple, quadruple that sample size. And so we've actually seen with other vendors that we didn't include here that only do subsample boosting, that there is some viability to focusing just on subsegments. But ultimately, that's something that you really can't validate in a meaningful way if you're that small. The minimum base size for Echo Index evaluation, because of the machine learning components, is around 75. So you're kind of going into well, we can either report nothing or we can report something. So it really gives us that capability in terms of having more confidence in what we're able to report out on for those small segments. The card flip question. I promised you the answer. So the cards shown were A, 3, 7, and F. You have to flip over A and you have to flip over 3 because the only rule was related to those two, that number and that letter. Anything else doesn't matter, doesn't refute the rule at all. So good question. So how have we gone about presenting sample boosting to stakeholders? Do we present the Echo Index alongside the results? What have we found to be the most effective at visualizing the validity of synthetic data while keeping it a cautious approach? So we've actually gone through a handful of these with our clients where I show that bubble chart or the lollipop chart directly. And then we show the effect size. So the effect size itself is ultimately the score. And then you can show the distribution alongside the lollipop chart. And I know that's a little bit more data sciencey than some execs may want to see, but everybody gets it. It's pretty easy to see as your lollipop within the bounds of where we want to be. If it is, then we have a discussion about the fidelity of the individual questions. So we'll go and we'll do that same filtering exercise and understand what are the top contributors, even if it's high fidelity overall, to the lack of alignment to the real data. And there's a quad map that I show that actually plots the stat score on one axis and the machine learning score, or the machine learning importance on another axis. And that's where you can see, do we have problems from one angle, both, or the other, in terms of the questions that are problematic. Beyond that, the same disclaimers come of this is synthetic data. This is a modeled approach to boost the sample. This is not real data that we collected. And my recommendation is always show two ends on your slides. Don't show a total. Don't say I have 1,000 completes. Say I have 500 real and 500 synthetic. Because ultimately, then you know you're being as transparent as possible as you're sharing these results.
And do you ever report the results separately? So say, hey, here's what the 500 respondents said, and then when we boosted it, here's what it said.
So, Aaron, that's a really good question. And my take on that is that's the same thing as providing weighted and unweighted results. If you're going to do it because you have to make a decision on one data set. You have one insight. So, are you going to trust the sample boost or not? If you're not going to trust it, throw it out. Same thing with weighting. If you want to have weighted results, there's no point in showing unweighted results. So, we haven't had as much of that as a stress test recently of show us both. I'm assuming we'll get there at some point. But my recommendation would be if you don't trust it, let's not use it.
Yeah.
Then we've got when you use the LM provider, how much context about the survey was input. So we provide the flat file and then we provide metadata. So the metadata has the question name, the question description, the answer choices, and then any logic in the survey. That way, the LM isn't just going blind. And we provide that same file alongside the data set to all of the providers that participated in our exercise. So everybody had the same level of information as we went into it, but it wasn't blind. Are we planning to make the Echo Index scoring code publicly available? Or if you want to run it, should we come to you? So at this point, we are the sole owners of the Echo Index. So we would encourage if you want to collaborate in any way to reach out to us and we can work that out directly.
Ben, have you found that you need to change the Echo, the components of the Echo as you've done new projects and found new types of data that you hadn't considered before, or areas where respondents aren't as confident in answers or things like that?
The biggest change that we made was the original Echo Index took the real data and split it in half. And we would assign synthetic to one and real to the other. We actually found that the sample size geometry affected larger samples when we were trying to do the Echo Index comparisons. So ultimately, if you had really small samples, you would have a very big band of your effect size, even though it should have been tighter, because we were effectively creating the baseline on half as much data. So we pivoted to using a bootstrap subsampling approach to generate those partitions that are of equal size to the original. And that was the pivot that we had to make because we were seeing unbelievable and unexplainable results. So that was the biggest change that we had to make along the way.
Thanks.
And the last question here, thoughts related to statistical testing of the synthetic data. So this gets into effect size questions. What is the effective base size questions? What's the effective base when you include synthetic data? So I guess I would need more on what statistical testing of the synthetic data means. Are we testing this against the real data? Are we testing it against itself? But ultimately, we would want to use the effective base size in terms of our N for any stat testing we want to do, as opposed to using the holistic base size across the board that we just have based on the number of rows we have in our data set. But good question.
Okay, that looks like it's it, and we're out of time. Thanks so much, Ben, Aaron, and everyone for attending. And we will send this recording out to everyone. And hopefully you got Ben's slides there with the QR code, and we will talk later. See you next time. Thanks, guys. Bye.
Thanks.
Thanks, everybody. Thanks, Ben.